This conference will now be recorded. This conference will now be recorded.
So today we'll be discussing about applications of data science. So this is a workshop, it's a 2-day workshop. So we would be discussing on what is data science, what are the basics of data science, and then we'll be also understanding about different applications, the life cycle of the data science, what are the jobs and responsibilities, understanding the big picture of all these things. So if you have already gone through some of the data science content or basics and all, probably a couple of things would be a little repetitive, but I would make sure that you have some clear cut of understanding of where this area is used, what are the things which are coming in the real world. So my name is Sitaram, and I have around 15 years of experience in 14 to 15 years of experience in IT, and I work as a data scientist for one of the MNCs. And I also give a lot of trainings with which I have been associated with Career IT for a long time, and I'm providing them the training which is in the space of data science and so on. I also do some Python related training, and that is provided. Just a second. All right. So what we are trying to look at it is what is data science? So today's topic would be understanding a little bit of data science and so on. So without any ado, let me start. So data analysis or data science, these areas of understanding data, this was there for a very, very long time. Now there are a lot of experiments which were done by famous, famous academicians, famous scientists who has worked in the space of data. Everybody was trying to understand how we can use this data and then how we can make the good sense of data. The experiments were ranging from 1930s and prior to the World War II and so on. And there were a lot of experiments in understanding like how we can apply newer techniques in the space of data. For example, machine learning, deep learning, artificial neural networks, all these things to make more sense of data. Those were there for many, many years. But why are we so much, if you see the hype cycle, we are currently in a hype cycle where again everybody is talking about artificial intelligence, everybody is talking about data science. They are trying to apply newer techniques of machine learning, deep learning, and so on. Why is that happening right now? So if you take a little step back, this is kind of a graph which is for the past few years and past few decades, I should say. So AI and data science were very, very prominent in 1950s when newer algorithms were developed. In the first, there were algorithms like perceptron models which were developed in 1950s and so on. And back in those days, people thought that this AI is going to change the world. Humans would utilize the AI for the better world creation and all of that. But again, it went into an AI winter. Now, what is an AI winter? AI winter is, in sense, there was a big hype in the previous years. So that was exactly 1958, where people were thinking that there was a lot of hype. Perceptron models, neural networks were created, machines were able to work on these analytical topics and so on. And then there was a big hype. And followed the big hype, there was this AI winter. The first AI winter was caused because of unavailability of data. So even they started creating a lot of good algorithms. Now, because the data was not available, we do not have huge amount of data, and that created a lot of problem, and it went into an AI winter. Now, second hype cycle of AI came somewhere around 1980, 1990s, where the new image-based recognition models have started. Now, the image-based recognition models, where we are trying to identify handwritten digits. Now, computers can look at the digits and then say whether it is a 1 or a 5 or a 10. Now, such kind of technology was used where we are trying to make computers to see and then make sense of the environment. Now, basically, they were trying to identify the postal cards. The US Department of Post, they were having handwritten zip codes, and the research was done to identify those zip codes and then to sort the postal cards based on an automatic manner. It was a very big project and it was a huge success. Jan LeCun, he was the researcher who was invented a new model algorithm called as convolutional neural networks back in 1990s, where that would be able to use to recognize handwritten digits. So it will make computers to look or see and sense the environment. Now, it is a very beautiful algorithm, but because it again went into AI winter, the reason is because uh, it does not have the right amount of compute and storage. Now, the first problem was where we don't have data. In this problem, we have data, like we have the images of all these different letters and so on, but what we are seeing is we are not having the right amount of computational power. We are not having the right amount of computational power, we are not having right amount of storage, so that we can store all this huge amount of information and apply this computational power to do a algorithmic process. No, that was the second phase. The second AI winter came somewhere around 95 to 2000 kind of phase, where people thought that it would go and change the world, but again, because we do not have so much of computational power, it went into this AI winter. Now we are currently in the stage right now. We are in this 2020 era, so this is a little dated, but we are in this particular question mark era where we are trying to see whether is it a bubble again, or will this burst, or will it certainly continue the same way, or it would be picking up and then we will be creating a lot of pervasive applications. So we are in this kind of a state. Um, Is there a question? I just want to check if my voice is clear and you're able to hear it properly.
Yes, we can.
Perfect, thank you. So if you have any
Yes,
questions, do stop me at some sensible time, and you can use the chat window. I would recommend using the chat window. You can post in the chat if you have any questions. I would look at the chat questions and then answer them as and when required. All right. And if you really think that you need to stop me and then you have to ask a question right away, uh, feel free to do that. But take your best judgment. All right. So let us continue. So I was talking about the current phase where we are having now the beauty we are currently in the phase is that we are having a lot of good things together. Now, we do have a lot of data. For example, we will discuss about what different types of data, where the data is coming and all of that. So we will discuss about all those things, but we are currently in a phase where we have huge amount of data collected from multiple devices and ability to store them. So thanks to big data, cloud computing, and so on, where we are happily able to store terabytes and petabytes of data. So that is the second thing. And we are also what we are also seeing is, just a second, I would request everybody to go on mute, please, if you're not speaking. Lakshmi garu, is there a way to mute everybody except me? All right. All right. Let us continue. I should be able. All right. So let us continue. What I was talking is we were discussing about something called as AI. Currently, we are in a phase where we have huge amount of applications which are developed. A lot of data is being getting collected, and because a lot of data is being collected, we are also having the ability to store it for a longer duration, right? So that is also a great advantage. Now the storages are coming from big data systems. You can think about file-based system, Hadoop, and other things where you're using this for a lot of process. Okay, so what we are also seeing is we will be able to what we are also seeing is we are able to um, not only store, but we are also having these newer algorithms which are coming, right? If you have seen, like from Google, Facebook, and different other bigger corporates, you are seeing that there are a lot of algorithms which are open sourced. A popular algorithm, TensorFlow, which was released in 2017, has become so popular that a lot of deep learning and machine learning work is being done by that framework. Similarly, there is another framework by PyTorch, which is from Facebook, and which is also providing similar kind of facility. Now, what we are seeing is we are seeing a lot of these kind of algorithmic process are also available, and all these algorithmic process are also helping for creating better systems. Now, what we can say is we are in a phase right now, which is certainly is there to stay at least for another 5 to 10 years, where we are seeing that AI and data science and machine learning, all these things are coming together to create systems which will be used for a better world. All right, so that is the phase we are in. So I am very, very optimistic in this particular scenario. I was saying that there is a huge amount of data available. Data is there everywhere. So, every year there's a huge amount of data increase also. Data is increasing from exabytes to zettabytes to even thousands of zettabytes, and it is huge data. And every year it is thought to be as doubling, tripling, and quadrupling also, based on the way and the pace at which is being collected. Now, if you see around olden days, we only used to have computers. Now, where we have very, very limited amount of data, maybe like 100 GB of RAM or 100 GB of hard drive is, or 40 GB of hard drive is a big thing, right? So I remember in 2000 or 1999, where I had my first system, 2000-ish. So I remember I purchased only a 40 GB of hard drive, and that entire system was costing me 40,000 rupees. Now for 40,000 rupees, you can build a state of the art machine with SSD drives, with GPUs, graphic cards, and the best of the best processors, right? So the way we are seeing it is the huge amount of data is there, huge amount of compute is there, huge amount of advancements in the technology is there, and because of that, there is a lot of ability to collect data. Now, if you are seeing what is the data which is collected, now the data which is collected is the first one. We call it as transactional data. Now, transactional data is nothing but the data which is collected by regular businesses. So if you are looking at a retail business, right, maybe like Walmart or DMart or Reliance Fresh. So you're looking at these retail companies, what are they collecting? So they will collect regular everyday data. Like somebody is coming, taking a loaf of bread, they are taking milk, maybe taking some cans of soda. So and or maybe in India they might be buying some rice, wheat, atta, whatever. So if you're looking at that, the transactions which are happening is the purchases which the customers do. That is from a retail perspective. If you're looking from a banking perspective, we are looking in sense of the bank transactions, how many withdrawals, how many deposits are done, and how much amount is left in the account, what is the average monthly balance, right? So if you are having an account in Bank of America or HDFC Bank or whatever, now the bank needs to understand all these transactional information. Now the analysis what they do from this transactional information, very very simple analysis like monthly average balance. You might have known that what is a monthly average balance. On an average in a month, how much will your bank will have in the account? Suppose you're getting a salary of 1 lakh Indian rupees, and then you spend you spend like 40-50,000, and your rest over 30-40,000 is left in the account. And so what you see is that particular amount would become your monthly average balance. So what the bank would do is collect all such kind of informations from everybody, and then it will get an estimate like how much of amount it can risk to provide a loan. So what is bank doing? It is taking money from you and then it is lending out to somebody else, right? So if the money flow is there from you and to somebody else, if it is sitting idly in your account, instead of sitting there, it can be circulated. So bank does the work of the circulation, but it should know some of the basic metrics like what is the average balance, so that I can bet on that. Now it would take a certain risk level. It doesn't entirely take. Now, if you see like the bank goes bankrupt, if you're aware about the Yes Bank, you would see that everybody is withdrawing money, and it would become a huge problem for them because the loans are not coming up and people are withdrawing money. It would become a very difficult stage, and the bank could go bankrupt. Now we are talking about transactional information. All those things, if you take retail, if you take banking, if you take media companies, healthcare, whatever we are taking, we are trying to understand that there is a lot of this transactional information which is available, and this transactional information will help you to understand what is the data which is being used. Now the second one, in the second slide, I would like to talk about audio and experimental data. Now audio data is a recent one, and it is in a lot of research. Now you might have seen the devices like Siri, Cortana, or Amazon Alexa, right? Echo Dot or whatever. So you're looking at those devices, and you are now thinking that now instead of you are doing UI based operations, maybe a web based operation or a mobile based operations, now you're talking. So world is almost moving towards a stage where we are going towards a no UI revolution. A no UI revolution, in sense you would not require any buttons or any laptop connectivity or mobile connectivity to connect to any device. Now you can speak to the device. Now we are only in a nascent stage where we are trying to connect maybe televisions, maybe AC or something like that. But in the future you would see, and the future is not very far, you would see every device is able to listen to your voice, right? Maybe your fan listening to your voice, maybe light listening to your voice, maybe every device, whatever you can imagine, every device will be enabled to listen to your voice, and then it will have its own identity. Now you can speak to them. For example, now I can say, hey Alexa, what is the weather today? When you're saying, hey Alexa, what is the weather today, what is actually happening? There's a lot of data related operations happening. So the data is in terms of my voice. It will take the voice, it will first has to decode what is it in the voice. So some of the operations convert voice into a text. For example, I say, hey Alexa, what is the weather today? Now it will take that entire sentence, convert into a text, and then once it converts into a text, then what it happens is it will then go into a multiple phase, right? So we are looking at a situation where we are seeing that the data getting collected, which is in the voice or audio format, speech format, and so on, and using that information, we are trying to do further work. Now there are a lot of devices which are coming in this space. There's a lot of research also happening. A lot of work is also happening. That is pertaining to the audio data. Coming to the experimental data, again, there is a huge amount of data analysis happening in terms of experiment. In fact, we are in a state where a lot of people are being impacted with COVID-19. And the COVID-19 and a lot of companies, the drug manufacturing companies, are working towards bringing vaccines. Now, if a drug company wants to bring vaccine, what that company has to do? Now, it has to try on multiple COVID patients, and then it has to understand whether the drug is working or not. Right? For that, there will be a lot of experimental analysis. A specific science of statistics, or a specific area of statistics, which is called as inferential statistics, is exactly working in this particular uh, in that particular area, right? So what is inferential statistics? Imagine there are 1,000 COVID patients. Now I can't test my drug on the 1,000 COVID patients. Now what I will do is I will try to take a sample. Now 1,000 COVID, instead of 1,000 COVID patients, I will take a sample of 100 COVID patients, which is representing the actual population, right? So I have 1,000 COVID patients. Now I have invented this new drug, but I don't want to test this drug on everybody. If I test the drug on everybody, if there is a side effect, maybe something very wrong happening, then the people will sue the company, and it would be a huge loss. So what the drug companies do is they first do multiple levels of clinical trials. The first set is to sample your actual data. So it take 1,000 patients. Instead of 1,000 patients, we try to do a sampling. We try to do a sampling of 100 patients. Now you take the 100 patients and then test the drug on that 100 patients. Now, even before testing the drug on 100 patients, you would do a lot of other experiments. You might do lab experiments with respect to different kinds of animals like rats and different other things. And then you would try to extrapolate the results to the 100 patients. If everything is working fine, then you would release the drug to the actual market. Now, this is the same thing which is happening for your vaccines also. So that is the experimental data. Now, this is the experimental data with respect to healthcare. There are similar experimental data with geoscience, meteorology, regarding to the electronic power consumption, the power grid, SCADA controllers. So you name it, every area, whatever we are seeing, there's a lot of work happening, and there are a lot of experiments happening, and this particular application would be helping. So data science is helping in a multiple ways to find out the best experiments, to find out the best results. The next one is video and image data. Now, video and image data is also very, very popular. Nowadays, there are a lot of experiments happening in the space of video data and image data. Now, video data, so IIIT Hyderabad, I know a very good professor out there who is working in along with Department of Municipal Commission. So there is GHMC Hyderabad, which is like Hyderabad Municipal Corporation. What they are doing is they are trying to identify using the CCTV footage or the traffic signal footage. They are trying to identify or create an online application which would identify if the biker is wearing a helmet or not. Okay, so if you're previously, what used to happen, there will be policemen standing everywhere, traffic policemen, and they will be taking the pictures, and they will be then posting the pictures, and you would get a challan after, say, like 5-10 days, right? So that is more of a very, very offline process. We need to be purely dependent on the policeman. If the policeman is not seeing the people, then it would the people will miss. So nowadays, what they're doing is a lot of experiment happening here, where they would try to put this CCTV footage and CCTV or the CCTV cameras and surveillance cameras would look at the traffic, identify people who are not wearing helmet, identify their number plate, and automatically cut a challan to the number plate. So that's how a lot of work is happening in the video analysis. So there we use technologies like deep learning, convolutional neural networks, where we are trying to identify video, detecting whether the people are wearing helmet or not, and then we are getting into the stage where we are predicting, okay, this person is not wearing helmet, and so that this is the number plate, so that let us cut a challan to that number plate. So such kind of experiments are being done. A lot of work is happening in this space, and that is happening automatically. Now, second is image data. Now, image data is even more aggressive. It is even more aggressive in the um, application of data science. Now, there are a lot of experiments with the space of media, healthcare, and other applications for using image analysis. Now, where do we use image analysis? For example, if you have seen the Google I/O speech of 2017 and 18, Google CEO Sundar Pichai has given a wonderful speech on detecting diabetic retinopathy using their Google's Verily application. So what Google has done is they have tied up with a couple of hospitals, eye hospitals in India. There are two eye hospitals, Shankar Netralaya and Arvind Eye Hospital. And what they did is they are trying to take the retinal scans of patients. Now in India, there is a huge rural population, and people get diabetes and slowly they lose the eyesight. It is called as diabetic retinopathy, where you lose the eyesight gradually when your diabetes levels are increasing. And basically what happens is within your retina, there will be these swabs or cotton spots which will be formed, and slowly gradually they increase, and then basically you lose the eyesight. Now what has happened is people do not realize that. So they think that, okay, because of the age or something, they are losing the eyesight. So using the diabetic retinopathy application, the application is called as Google Verily. Google Verily, what it does is it uses image-based analysis to take retinal scans. So the device is a simple camera, HD camera, which would take the scan of an image of an eye, retina, and then it will scan that image instantaneously to identify whether the person is having diabetic retinopathy and to what stage, to what level he is having diabetic retinopathy. So such kind of applications are being developed, and we are using a huge amount of such kind of systems where we can use this data, and a lot of work is happening on the image data and the video data. Next understanding is to understand about the graphs and charts and stats. Now these graphs and charts, they are also very, very popular. For example, if I look at a graph, if I look at a chart, and based on the graph and chart, if I can make sense like what is happening, then you will be able to identify the patterns. You might have heard about the word like picture is worth more than 1,000 words, right? Now, because if I am representing something in terms of pictures, now instead of giving tons and tons of data, you can represent in terms of pictures, which is showing some trend. So if you're seeing a stock, for example, US stock market is plunging for the past 2 days. Imagine that is the news. So if you're seeing like, okay, US stock market is plunging, so how do we identify? If I give some rough numbers of 10 days worth of data, it becomes very difficult to identify whether it is going up or down, whether it is going up today, going 3 days down, 2 days up. If I want to do such kind of understanding, it becomes difficult. But rather, if I give you an area chart or maybe a line graph, then you would see that there is a trend which is going up, or it is going down, or suddenly there will be a drop, right? So when you kind of identify such kind of patterns and data, you can do a lot of analysis. So there are certain kind of other data elements like understanding charts, understanding graphs and patterns, and using that, data science makes a lot of meaningful insights. So data science also combined with a very important topic called as data visualization. In fact, they go hand in hand, because data science is all about talking about data. We would like to create a story or make an understanding or get an insight of a data. So for which your data visualization is very, very helpful. So once I can create a story, once I can understand the data, what is happening, I can present that to the higher officials saying that, okay, this is the trend, this is happening, this is the reason the car sales are up, or this is the reason the car sales are down. So you will be able to make sense of your data. All right. So these are some of the data related elements. Now, before we go deeper, we would need to understand this big gimmick. Now, what is artificial intelligence? What is machine learning? What is deep learning? And what is data science? Now, this is a bigger question many people will have. Now, there is a place in Hyderabad called as Amirpet. This is just for a joke. Okay, don't take it seriously. Take it with a pinch of salt. So, what that place is like, if you get a new technology, the next day you would see a big banner saying that the person is having 10 years experience in the technology, and then they will be creating a course. Now, the reason that is, if you see that there will be different courses telling that, course on data science, course on artificial intelligence, course on machine learning, course on deep learning, course on XYZ, right? Now, people who are laymen or maybe who are not acquainted with the information, they might think that these all things are different. Now let us understand what is artificial intelligence. Now, artificial intelligence is a more of a broader umbrella. Now, this is more of a general term or a general sense in which it is coined very, very long back. And back in those days, what people used to think is, let us make computers to do the work of what humans are doing. Okay, so let us make computers to do the work of what humans are doing so that humans can do something else, some other productive work. So there are a lot of these repetitive tasks which are being done. So what computers were given is, computers were given some logic, computers were given some rules, some decision making. So what it would do is the computer would apply that logic. So the logic would come from a human. So subject matter expert would provide that logic saying that, do this if this happens, do that if that happens. Then these are clear set of rules which are defined, and the computer, what it has to do, just to abide the rules and then perform the actions. Now that was primarily termed as artificial intelligence. Now artificial intelligence will have a set of rules or logic, and then we will ensure that the computer is working on the rules and logic for doing a certain task, where humans are relieved from the task, and then humans can do something else. Now, in current days, we are calling this as automation, right? Automation, you might have heard. Different automation tools are there. Your software automation, your robotic automation, your process automation. So all these things are typically coming, are the sub branches of, I would say, artificial intelligence. Now, in that automation, what we are having, we are creating that set of rules. You are creating the set of rules and then saying that, okay, do this if then else rules. You do this if this happens, do that if this happens, and so on. And that is how it works. Now, what we are seeing is, if you take a simple example of a manufacturing company. So imagine you're manufacturing some boxes. So you will see these carton boxes of packaging boxes, right? So if you give a plain sheet of carton, there will be a robot which will be creating a boxes out of the carton. Now, how would it create boxes out of the carton? First, it would take a plain sheet, then you'd fold in the right side, fold in the left side, then turn it around, fold it back, and then it creates a box. Now, that is a automated process which is given as a set of rules. Then the computer will actually follow the rules and then create this box. Similarly, in process automation, you see that if something happens, trigger an email. Okay, so that is also a process automation. You see like, okay, some file is not there, then trigger an email to the production support so that the file, people will go and start create a ticket automatically so that the people will go and look at it. So that is also in artificial intelligence. So you would think that this all set of rule-based creation is more like a bigger umbrella where we are trying to give these rules so that it will understand the rules and then basically behave on that. That is artificial intelligence. Now, what is machine learning? So when we are coming to the machine learning, instead of we giving the rules, can the computer identify the rules by itself by looking at the data? So that is a bigger question. So people were thinking for a long time that, instead of me giving all the rules, which would expect the person to be a huge expert, right? So unless until the person is an expert in that particular domain area, he or she will not be able to provide the set of rules which will be governed. Now, if the rules are very simple, do step 1, do step 2, do step 3, it is easy to write. But if there are very complicated rules, it creates very difficult for somebody to create such rules. So there was a thought process that if at all we give a data and machine itself automatically use some statistical techniques to make sense of the data and then create the rule set. Understood? So the machine itself creates rules based on looking at the data. It uses something called as statistical techniques. Now, throughout the data science course, we need to understand a lot of statistical techniques. Now, there are a lot of statistical techniques in the space of machine learning. So those all need to be understood. So bottom line, machine learning is a subset of AI. It is a subset of AI in which it is ensuring that machines automatically look at the data, create an understanding, and then create this statistical output. The third one is deep learning. Now, machine learning is good. Okay, it is understanding the data and all of that. Then what is deep learning? Deep learning is one kind of machine learning technique. There is a machine learning technique called as artificial neural networks. Now, artificial neural networks is called as deep learning because it creates deeper neural networks which are having more hidden layers. So the new fancy name was given as deep learning, but it is nothing but one of the machine learning technique. Now, that technique has a beauty that it can work on different types of data. Now, what are the different types of data? It can identify, it can work on images, it can work on speech recognition, it can work on heat samples, sensor data, maybe text data, video information, and so on. All these kind of different data types can be used in deep learning. Machine learning is more specialized for structured information, structured processing, structured analysis, and so on. Whereas deep learning is working on the new age data systems like images, videos, the experimental data, all those things, whatever we have seen as an example. Deep learning works on those things and then does the same thing. So it will try to identify algorithms which can make sense of the image data. Looking at an image, it should identify whether it is a cat or a dog or a laptop or a desktop or whatever, right? It should be able to identify all those things, and then it will make sense of the data. All right. So that is something which these systems are trying to do. Got it? And now understanding artificial intelligence, machine learning, and deep learning. This is good. Now people will have a bigger question that then, sir, what is data science, right? So data science is a much more a much more complicated thing. Now it is connecting all these dots. For example, if at all I want to do some machine learning, now machine learning is more a technical thing, right? So it is applying some algorithm, getting pattern, identifying the relation between input and output, creating a representation and all of that. But how the data is how the data is collected, what are the systems the data getting injected, how we are doing any transformation, because when I am taking the data has to be transformed. It might be in a raw format, it has to be transformed into different forms, so that I might have to apply all those transformation techniques. Now, how the data is transformed and how we are using other things, so those all things we need to ensure. All right, so connecting all these dots will be done by something called as connecting all these dots will be done by something called as deep learning, or so something called as data science, right? So what is data science? So what it does the data ingestion. For example, there will be systems like databases, there will be systems like file system, log based system logs or transaction logs, clickstream data, images coming from different systems. So all this data we will need to ingest into a centralized place, so that I can do data analysis on that. Now, ingestion comes as a part of data science. Then you do some transformations. You identify there are any missing values. You find out value added, non-value added columns, remove some of them, add some of them, transform your existing data. So all that stuff would be part of data science. Machine learning or deep learning is one of the area. We call it as modeling. So in the entire gamut of data science, one of the area is the modeling, which is the machine learning or deep learning, where we try to understand the data, create the pattern of the data, and then create a model. Now the model is kind of an executable which could be used for doing future predictions using the data science. Now data science will also involve in deploying these models. Now the model, if it is created, you will not keep the model in your laptop or a desktop, right? You will try to deploy the model onto a cloud. So when you're deploying the model onto a cloud, you need to ensure that how your model works, how is the how is the methodology to deploy. Now how you connect, how do you create this entire deployment strategy, how do you use Docker, or how do you create RESTful APIs so that you can create endpoints for consuming the model, and all these things, right? This is more of an online thing. So you can also create a batch-based process. Now, if I'm creating a model, how is it serving in the batch? Now, how you create an environment where it triggers every day in the morning, 12 o'clock, and then execute the job and then finally give an output. So all these peripherals, you are seeing all the peripherals which are connecting the machine learning, artificial intelligence. So when you're connecting all these things, you call it as data science. Right? Are you getting it, guys?
Yes, we are following.
Yes.
Yes, sir.
Sitaram, I have one quick question.
Yeah, go ahead.
Actually, you said like in the case of machine learning, I think it will set their own set of rules and all, right? Does the machine learning really set the rules on its own, or we are making them to set the rules?
Machine learning does the rules. If we are setting the rules, it comes as an artificial intelligence, more of a rule-based engine, right? In machine learning, what happens is it will automatically set the rules. It will provide us the rules. In fact, we just have to provide it the data, and using the algorithmic process, it will create the rules and then provide it to us. Now that we can call it as model. Technical name is called as model, but model is nothing but a rule extraction of the input and output data.
Okay. Basically, model will create by machine or the developer kind of thing.
Machine in sense the computer. So you would write the code for that, like how to extract the logic. You
Yeah.
have to code, right? Of course, developer will write
It's a kind of tool, right?
It's a kind of tool. Yeah, you can say like a tool. Then now you are trying to use the tool to extract information from the data, and then it will create an understanding of the data in terms of a model, and then you can use that model for further analysis.
It can be used for any data.
Got it. Thanks.
Any data,
Okay.
yes, it can be used for
Got
any
it.
data.
Sorry, Sitaram, it can be used for any kind of data, right?
Yes.
Okay, thank you.
So there is another question, like in which format the audio data will be stored. Audio data will be stored in binary format. Okay, it is stored in the binary format in databases. Typically, your regular relational databases can store binary data, but they are not very well suited for indexing and other things. So there are other NoSQL formats. For example, you might have heard about MongoDB or Cassandra or Drake. These are other NoSQL based databases which are very well suited for storing different types of information like image, audio, and other things. And there are also file-based formats like Hadoop, big data systems. You also have storage systems from cloud. Different cloud-based providers provide different cloud storages. AWS does something called as S3, which is called as a cloud storage, simple storage service. Similarly, Azure has Azure Blob Storage. Google has Google Cloud Storage. All of them are providing ability to store different kinds of data. Now it follows audio, video, text, and different other formats. Got it? So
Yep, got it.
great. Let us continue. Or what I'll do is, what is the time now? Can we take a quick break here? A quick 10-minute break. We're just nearing to the 1 hour mark.
Yeah, sure.
Yeah, sure.
We'll take a small break here. I'll come back in 10 minutes and then we'll continue. So we came at a logical point. So next we will be talking about different applications of data science. We will spend around 1.5 hours again after the break to understand different application areas and what are the different things involved in that. So before
We'll
I
be back
break,
at 8:10.
yes, so 10 minutes will take. But anybody have any questions? I would like to stop here and ask, are you following it? Is the pace okay? The voice modulation okay? Everything's fine?
Yeah, everything
Not
goes well.
Yeah, it's perfectly all right.
Yeah, it's good.
Yeah, it's perfect.
all right. So we'll take a few minutes break. Take a 10-minute break here and quickly come back. What we'll do is we'll continue the next part. I will talk about different application areas. What are the data science tools required in the application areas, and I will take it forward. All right. Thank you.
Thank you.
Hi friends, welcome back. Before the break, we were discussing about something called as um, application. Before the break, we were understanding about artificial intelligence, machine learning, and other stuff, right?
Um,
Is there a question? Can you unmute yourself and then speak?
yeah, sorry. Yeah, can I have a quick query? Yeah,
Yeah. Go ahead.
yeah. Before this slide, we have a graphs and charts we have spoken about. Yeah. Basically, my client has a last 5 years data, including this year. Okay, based
Mhm.
on these last 5 years data, should I show the predictable values for next year to
Hmm.
2021?
Right.
Will it be coming under data science or like artificial intelligence, machine learning? I mean, which module should I go?
So as I'm saying, all those things are related, right? So for example, that is the task. Okay. For
Yeah.
past 5 years data you have, and then you want to do some prediction. What are the
Yes.
things will involved? I need to collect that past 5 year data. I need to think like
Yes.
where this past 5 year data will be stored. Can it be stored in Oracle databases right away, or should I take it out and then keep it in some other file-based storages, right? Or should I keep it in a cloud? Right? So that
Okay.
is also there. Then for past 5 year data, imagine there are 100 columns. Is that 100
Yeah.
columns required, or should I take only 40 columns or 32 columns? Then I have to do some transformation. Some data might not be there. You might have to join some tables. So then you do all this work. After
Yeah.
that, then you apply a modeling. The predictive, whatever you're saying, that comes under machine learning or deep learning, right? So it's called as
Yeah.
modeling. Then we
Yeah.
apply that modeling, saying that, okay, looking at these 32 columns, I'm trying to predict the sales of 2021, projected sales of 2021. Imagine, okay.
Yes.
So then you would use machine learning for doing that. And once you
Okay.
do that, then again you have to show some graphs, like graphs or charts, kind of
Exactly.
predicting, right? Then you would take the output of the machine learning model and link it with some important input columns, and then you will project some graphs. You would use some tools like Tableau or Power BI or some proprietary tools like Matplotlib, Seaborn, and all. So then you would use that, and then you would do the projection.
Okay.
Now, if you're seeing, there are a lot of things involved, right? So when
Yes.
you have, say, you have data, now what next is the bigger question. How do you, I'm sorry, how do you take it to multiple levels, and how do you do processing? How do you apply the modeling, and so on. So that
Yeah.
is data science. One part of that, one part where you are trying to apply the predictive analytics, like we are trying to do the prediction, future prediction, that is
Yeah.
called machine learning.
Okay. It covers all the modules. Okay.
Correct. And depending what to predict, now that is also a bigger thing. So if I am predicting some outputs, like should I give loan or not, that is coming as a classification problem. We will discuss some of them, but
Yeah.
what to predict is also a bigger question. So I am predicting sales of Maruti cars is coming under something called as a regression problem, where I am predicting whether the next Maruti Baleno model will be hit or flop, will be a the other problem, right? The
Yeah.
just a second. So that is what we were discussing. Let us start another understanding. We will understand about the applications of data science. So first and foremost, which I am talking about, an application of data science is so again there is a question. Let me answer that and then go. Does ML takes audio, video, images, and input like deep learning? As I told, ML also takes these data, audio, video data, but problem is ML requires something called as data pre-processing. I have to do some data pre-processing techniques. For example, if I am giving a image of a dog, for ML, I need to say where is the dog, what is the color of the dog, how the dog look like, what is the shape of the dog. See, all those things you need to provide as something called as parameters. So that is called as feature extraction. So you have to tell what are the features of the dog. Then only machine learning will be able to understand whether it is a dog or a cat or a laptop or a mobile and so on. So that is a difficult part in machine learning. We could do machine learning on audio, video, image data also, but the problem is we have to do the feature extraction. The feature extraction is a tough process. In olden days, before the deep learning came, people used to do all this feature extraction, identifying the patterns of the data, images, if in text processing, identifying parts of speech, how the language intonation is changing, all those things be a part of machine learning. But because deep learning came, all those things are taken care by the deep learning, um, and people don't have to worry about that part. All right, so that is about deep learning. Coming to the social media analytics is where you're having a lot of these social media companies. Now I would say these are the pioneer companies who are building this entire space. Now the space of Facebook, YouTube, LinkedIn, all these companies, they are trying to build the better systems. What they are doing is they're trying to create algorithms in which they're trying to create systems in such a way where we are using these applications for better analysis and so on, right? And so these systems, what they're creating is they're creating newer algorithms, like Google. They have created algorithms like TensorFlow. Facebook have created algorithms like PyTorch and so on. Likewise, every company is pioneering and creating a lot of similar kind of data science tool set. Now, these tool sets are being used by plenty of other companies like regular business companies, insurance companies, banking companies, media companies, retail companies. They're all using these pre-built frameworks for building even more better systems. There are systems with respect to data analysis, systems with respect to predictive analytics. A lot of those applications are being built, but the prime focus or the first cut systems which have developed are developed by social media companies. So I would say that's the reason I would say these are pioneers in this space of data science, machine learning, AI, and all of that. Now, once these companies have developed all these good tools, like now the famous tool TensorFlow by Google, now that is used everywhere by all the companies. And what we are trying to do is using that we can create some better applications. So using that, some other companies like banks and financial institutions, what they used is they use something called as predictive analytics. Like one of our friend was asking, like they have 5 years of data, they want to do something future prediction for 2021. So that comes under something called as predictive analytics. We are trying to use past data, and then based on the past data, we are trying to do future predictions. Now, this is used for many years. This is not new. Predictive analytics is not new. Many people are trying to do this for many years, but the problem is they were limited to limited amount of storage, limited amount of compute, and all of that, and which is giving bigger problems. Now, to avoid that, now with the use of data analytics, what they have done is um, just a second. Um, so coming to the predictive analytics, what predictive analytics would do is predictive analytics is where we are trying to look at the past data and then doing a future prediction. Now, future prediction is, we don't know, we are not certain about what future is going to happen, but we can do some educated guess. Okay, looking at this data, future also the same things can happen. That is what we are trying to, create. Right, so that is more of a futuristic purpose. We are using future, so we can use futuristic things and then create it as for future applications. Now, most of the companies like banking, insurance companies, financial companies use this pretty well. The older systems which are using predictive analytics were not so expandable. For example, they are mostly certain to one single systems. A small amount of data processing can happen and all of that. But thanks to big data and cloud computing and all of that, nowadays systems are being able to run on multiple cloud-based providers and all of that, and then we are able to expand it to a bigger space. Now, that is the reason with the use of artificial intelligence, machine learning, and deep learning, and combining with cloud and big data systems, they are able to create even more better predictive models. Next other important application is fraud and intruder detection. Now, what is fraud? Now, fraud is nothing but something which is not following a regular trend. Okay, so something which does not follow a regular trend, we can mark that as a fraudulent transaction. Now, how do we identify these fraudulent transactions? Now, identifying the fraudulent transactions also becomes a very big difficult thing. Now, in data science, what we do is we try to do something called as anomaly detection. So it's an algorithm in which we try to identify anomalies. Now, what are anomalies? Anomalies are some systems which are not following your regular trend. They are not following your regular trend. They are different from your regular data. That is called as an anomaly. Now, how do we identify that anomaly? Imagine I plot a lot of data transactions for the past one year, you would see most of the transactions will have a similar pattern, or they will be grouped together. But there will be some transactions which are away from the group. So this is like if I plot huge amount of data, you would see that most of the transactions follow a regular pattern, but some of them does not follow the same pattern. They would be a little away. So those are called as anomalies. Now, for an example, let me take, I am a regular person, like I get, paycheck by the end of the month, and, I would go, buy groceries. I would once in a while, I'll go to shopping. Once in a while, I go to movies. Once in a while, we go to restaurant for eating out and so on. Now, this is a regular life. So imagine the spending goes around like say like 5 to 10,000 rupees per week. Then something like 30, 40,000, 50,000, whatever per month is the regular expense. Imagine suddenly you see on a credit card, my credit card, there is 1 lakh transaction which has happened. So what happens is I immediately get an alert saying that there is this 1 lakh transaction which has happened on the credit card. Please authorize whether that is you. Okay, so how this identification of this anomaly happened is we try to identify the past pattern, and then we see like what is your regular spending pattern, and if there is something which is different from the regular spending pattern. For example, this month I would like to purchase a bigger 4K television, so we wanted to purchase a 4K television. So for that we have taken this. But what has happened is we thought that the 4K television, uh, we've taken the 4K television, and that has costed some 1 lakh, 2 lakh rupees. But that was not my regular pattern. So there are things which are different from your regular pattern of spending that can be flagged as anomalies, but they can be real transactions also. So generally, what they do is they will keep it separate, try to have a process in which verification happens. For example, they call you or message you or probably block the card, and then when you react to them, then saying that okay, I'm not seeing, my card is not active and all, then they will reactivate it. Now that is the process in which all these things happens. And this is called as fraud and intruder detection. Fraud is the transactional thing. Intruder is something anomaly access happening. Now, using anomaly detection, we could use that. Next application area is sentiment analysis. Now, sentiment analysis is a very interesting application area of data science, where we are trying to find out sentiment of the user based on the text data. Now, using natural language text data, mostly English, we are trying to identify the sentiment of the user. Now, in 2009, 2010, we did analysis. In 2010, we did initial project analysis, and I used to work for one of a rental company. So your rental company, and it's a purpose was they were giving some cars for rent. And what they do is they had this voice of the customer portal. Okay, so voice of the customer portal, back in those days we don't have so much of adoption of internet and all, right? So they were having this web portal where people can log into the web portal and then provide it. Now phones are also not so much of active this thing. They used to go to the website and then they can provide their feedback about how was their journey. For example, they rent a car, they go to airport, rent a car, go through 3 days, 4 days, they have the car with them, and then they return the car. So when they're throughout the process, the feedback would take like how was the rental agent's behavior, whether they are satisfied with the cleanliness of the car, whether the car is driving smoothly or not. So other performances, right? All those things will be measured, and then based on that, we will try to give some rating to the rental center. Okay, so that rental center or the rental station will get the rating that whether it is good or bad. Likewise, we can take the ratings of all the rental stations within a particular zone, maybe like a district or maybe like state, and then basically give like which area is most happy, which area is having more complaints, which area is having some other related issues and so on. Based on that, we do it. So that project was called as voice of the customer portal, where people will enter their feedback saying that, you know, car was neat, but the rental agent was very rude, and he did not check out my car on time. He has added an additional fee, late fee, or something like that. You know, you try to give some feedback, and that feedback is accounted. On those days, the primary focus was to identify sentiment with respect to positive, negative, and neutral. And the sentiment analysis was very, very simple. We are trying to identify, looking at the sentence, whether it is a positive sentence or a negative sentence or a neutral sentence. Now, how do I identify positive sentence? We have collected a lot of positive, negative, and neutral sentimental words. Every word was having some weightage. For example, good, great, and awesome. If these are the three words, good will have rating of 1, positive 1, great will have rating of 2, and awesome is having a rating of say 4 or 5. When you're looking at these different things, you look at saying that, you know, everything has a different sentimental value in it. Okay, so you have good has minimal, better has, oh sorry, great has little more, and awesome will have little more. Based on that, we take positive sentiment, negative sentiment, and add all the individual sentiments. If I have a sentence that the car was very clean, okay, so the car was very clean, this is a positive sentiment. So how did I get it is a positive sentiment? Very clean. Clean is a positive word, and very clean is even more positive. So based on that number, based on simple number counting, we will be getting the positive, negative, and neutral sentiment. But nowadays, people are trying to create more entity level sentiment analysis. Now, what is an entity level sentiment analysis? They simply don't want to get like neutral, average, or neutral, good or bad. They want to go even to every entity and then identify what is that sentiment of that particular entity. Now, if I go to an Amazon comment about a mobile phone, okay, so a mobile phone Amazon comment goes like this: the look and feel of the mobile is great, the build quality of the mobile is great, the camera takes crisp pictures, the battery backup is also good, it will run for 2 days, but the front facing camera is very bad. Imagine this entire sentence is the comment provided by some provider. So customer has taken the mobile and then he has provided this feedback. Then from the feedback, what we can identify is there are 4 or 5 positive things about the mobile, but the front facing camera is bad. Maybe everything is good, but the front facing camera is like 1 megapixel and so on. So if somebody who is like a college guy, who is like a selfie freak and so on, and then if he wants to take a lot of selfie pictures, post on Insta and so on, then he would not like to take that mobile. But for somebody like, you know, somebody who just wants to get a good battery backup, somebody who is elder, like he is not worried about taking selfies, but he should get a very responsive mobile. It should be working well, build quality is good, and it runs for 2 days. If at all those are the requirements, then, you know, for them, for such kind of applications would be very, very good. So sentiment analysis goes deeper level. So it is called as entities. So it will try to identify entities. What are the entities? Battery backup is an entity. Build quality of the mobile is an entity. Front facing camera is an entity. Back facing camera is an entity. Likewise, different entities are there, and then based on their different entities, we are trying to create better systems. Got it? So those better systems, what we do is we try to create those better systems, we try to apply those systems and then use the systems for our analysis. So using these better systems, what we can do is we can create even more better applications and so on. Got it? Let us go forward. Another interesting applications in the space of data science is self-driving cars. The application area which is used in this is called as reinforcement learning. So self-driving cars is a very complicated topic, because if you are looking at a car and a self-driving car, a car will have lot of sensors. So it will have a 360-degree video camera. It would have a proximity sensor. It will have a gyroscope, speed sensor, acceleration sensor, different other steering angle sensors, braking, acceleration, multiple other sensors will be there, based on which the car has to take some decision. Now imagine the car is trained to stop at a red signal. Imagine it is approaching a red signal, and if it did not stop at the red signal, what the reinforcement learning models will do is it will try to apply some penalty. So penalty and reward based mechanisms will ensure that next time whenever the car is driving, and if at all it sees a red signal, it should stop. Right? Slowly the car learns like how how to maneuver, how to behave at the signals and all that stuff, and slowly day by day it will try to adapt by its own, and it create a better model. So what that will do is it will try to create the systems in such a way that we are trying to create better applications. It will try to create better models, and then using that we will be able to create these applications. Self-driving cars is a very interesting technology. A lot of work is happening in this space now. It uses something called as reinforcement learning, which is a sub area of machine learning, which is primarily focused on doing something what we call as supervised machine learning along with a feedback mechanism. Another technologies which are classification and clustering. So I was just talking about an example about futuristic prediction. Now if the prediction is belonging to some classes in sense categories. For example, I want to predict if I'm applying for an H1 visa, I want to predict whether my H1 visa will be approved or rejected or withheld or whatever the other state. So whenever I am trying to predict all those cases, in those things, what I do is I try to do something called as classification. Right? Classification is I am trying to classify or categorize into one or the other categories. That is called as a classification technique. Whereas clustering, there is another technique called as clustering, in which we are trying to group your data based on a specific grouping. The grouping can happen where I am trying to find out similar patterns. Imagine there are a bunch of customers, and then I want to find out their purchase patterns. In the purchase patterns, I am trying to grouping into one or the other categories. So for example, you're trying to say like these all customers are only buying electronic products. These are all customers are buying some groceries. These are customers who are buying only clothing. So when you try to identify their purchase patterns, the behavior patterns, and so on, and then I group them into those categories, that would create these systems. The next interesting application areas are called as recommendation engines. Now, what are recommendation engines? Now, recommendation engines, as the name suggests, they are trying to do some recommendations based on the already known data. Now, in this, we use a machine learning technique called as association rule mining. Now, what is association rule mining? Association rule minings identify associations between the product. Now, how are they associated? If there is a product A and it is very closely associated with the product B, then what I can say is if somebody is buying product A, we can also recommend them to buy product B because there is a very high closely association. People who are buying bread, we can say that they can also buy jam, they can also buy butter. People who buy soda, they can buy chips. Similarly, you might see that lot of things, people buying toothpaste will buy toothbrush. So you might see that lot of associations will be there, and then using the associations you can build recommendation engines. You can build some offers, combo offers. You can create different strategies of applying how the aisles will be there in the shopping complex, right? So all those things, where the position of the products will be, right? You would keep bread and jams at the same place so that people who are buying bread, they can also take the jam and then go home. So, and you can also create strategies in which you can create combo offers. So you can say like people who are buying the toothpaste will get this toothbrush with for 10 rupees off. So when you're doing this kind of offers, what people will do is, even if they're not interested, they would see that, okay, toothbrush is coming for 10 rupees off. And anyway, after a month, I would require a new toothbrush. So why not take it? So they will purchase that particular product, even if it is not required, they will purchase the product because they see some value. They are seeing this combo offers and discount offers, coupons, and so on. And then they think that it is advantageous, and then they try to use it for their purpose. Those are all part of something called as association rule bindings. They are also called as the recommendation engines. Now, recommendation engines have so many applications. Now we are seeing recommendations in YouTube. Now, how does it know that if at all I am watching all cricket videos, next time it will recommend a cricket video? Imagine I am I'm doing some learning in data science. The next time you would see that there will be some recommendation from some institute or some college or something, or some recommendation on data science related videos will be coming. If I look out on some other things like entertainment, movies, songs, and so on, then you would get related recommendations will be provided. Now, all that thing will be part of something called association rule binding in data science. Another application area which is about the transportation and the car sharing. You might have very well aware about Uber, Ola, Lyft, and these companies which are providing this taxi and cabs and car sharing based business. Now they use data science very heavily. For example, I give a couple of examples. I will take Uber only. So you know about the surge pricing. So surge pricing is nothing but whenever there is a huge demand, you would try to bump up the prices. Now that is a very interesting use case, because if you are seeing that at a particular day, at a particular time, at a particular location, you are getting huge demand and you know that there will be demand, then what you do is you automatically bump up the prices. When you bump up the prices, your prices will be more than the actual price, and then you will get that additional advantage. If you give the car for say 100 rupees, and if you're bumping up 20 rupees or 50 rupees because you see there is a demand in the cars in that area, a lot of people are trying to book, then what you do is you bump up the prices so that you can easily get the 20 rupees advance. I have literally tried it, experimented also for these car companies. So imagine you get down on a train station. So you get down by some train, and you try to book a cab. If you book a cab right away after you get down the train, you would see the car prices would be somewhere around, so 100 rupees is the worth of the cab. It would be somewhere around 250, 300 also. Because a lot of people are booking and there will be a surge applied and the prices of the cars go up. So imagine you rest for say 10 minutes, you just sit back and relax, don't just rush away, just sit in the station, and then you see the car, slowly the car prices come down. And I have experimented it personally, because this is happening purely based on the surges. If there's a lot of demand in the particular area, then the surge automatically get applied. So the 200 rupees car or 100 rupees car, you need to pay for 250 rupees. Imagine you stay calm and then stay there. The 100 rupees car, again, you would get it somewhere around 220 or 230, sorry, 120 or 130, and then you can book after 10 minutes. There's no rush. So how Uber is applying is, it will look at by location, by time, by day, by place, and it would apply this search-based mechanism, which is purely counting numbers, and then based on the sum count numbers and the threshold values, you will apply the searching, and the search get applied, and then a company will get benefit out of it. Similarly, Uber also provide driver location, and this is called as hotspots. Now the Uber says that it is hotspots, where it will tell that this particular place you would get a lot of bookings. The probability of getting bookings is very high in that particular place, and the way it will come to the conclusion is, it will look at past data, it will look at a lot of transaction data, and then come to a conclusion that what are these hotspots. Imagine in a busy IT corridor, every day from 5 p.m. to 6 p.m. or 6 p.m. to 7 p.m., there are a lot of cab bookings. So what you can identify is this IT corridor every day, every weekday, the 5 p.m. to 7 p.m. is a busy zone. A lot of cab bookings happens at that particular place. So then what you can do is you can place the drivers at that particular place during that time. So generally, these Uber cab drivers, they can speak to the customer care agents to understand what is the next place where they can go and get the cabs. In that manner, what they do is they will try to identify, and they try to create systems. So what they do is they will call the call the cab agents, and then they will say that, okay, go and stay in this so and so place. The way they get is they will get it from the hotspots. So they will understand that, okay, so and so place there will be a lot of cab bookings happening, so that I can go to that place and then I can stay there. Now that is based on something called as the cab guys will know based on the past data, and then they can clearly say that, okay, go and stay there. That is called as transportation and car sharing industry. Next, another interesting use case is on there is a question, are you sharing any video? I am not sharing, I'm sharing a presentation. Are you not able to see it?
We can see it.
Yeah, okay, thank you. So next topic is about human emotion analysis, and this is basically again a very interesting area in data science, where people are trying to look at human facial expressions, and then based on that we are trying to identify the positiveness, negativeness, or the emotions of the humans. Now there is a lot of work happening in this area where they're identifying the human emotions, because in the future we would be completely there will be humanoid robots which will be completely dominating. That means that wherever we are having a monotonous job and more repetitive jobs where a computer or a robot can replace a human, that will be replaced. For example, say a hotel receptionist, right? Imagine a hotel receptionist, you are trying to address to the hotel customers, or probably if they're having questions, they will answer, you can be answered. And if at all somebody is coming for a booking, you would take the booking and then give the room. So this is the work. Such kind of things are getting monotonous. Wherever a customer facing job which is almost monotonous, such kind of jobs can be replaced. But while that replacement is happening, we need to create more intelligent applications. It is not like if and else question answer based systems, which can be easily available right now also, like kiosk systems. You get in, you key in the ticket number, and then it will say, for example, in airports you would see these kiosks where you key in the PNR number, and you would be able to do the self check-in. So such kind of systems are already there. But if you want to create more intuitively, they're trying to create humanoid robots. You might have heard about something called as Sophia, which is a humanoid robot which will look at humans, identify the human expressions, and based on that it will try to answer it. And how this human emotion is detected is based on the facial expressions. Now once the facial expressions are captured, we will identify what are the different types of facial expressions, and then based on that we will try to get the meanings of that and then behave accordingly. For example, if I'm going to a hotel receptionist and I'm saying, hey, hi, my name is Sitaram and I have the booking for today, then it will say that, thank you, sir. I will look at the reservation. It will look at the reservation and then say that, oh, yes, we have a reservation. And while this entire thing is happening, I would also give some recommendation. I will also ask saying that, can you book a beach facing room, or a room with higher floors and so on. And based on that it will take the request and then apply that. So when this all conversation is happening, there could be some human emotions. I would be happy, I would be angry, I would be complaining, I would be asking some questions. So based on that, the robots have to act accordingly. If there are, for example, if the person is angry, the facial expressions would be different, right? His voice modulation will be different. So based on all these parameters, the system has to take some meaningful decisions. So such kind of systems are being developed. Genomic data analysis is also a very, very interesting use case. In fact, in 2000, 12, 14 time frame, I worked on this project, which is purely working on genomic data and pattern finding of genomic data. Now, what is this genomic data analysis? Is like, if you look at animals, you would find similarities in genes from animals and that of humans. For example, I compare with a rat and a human. What is the similarity of a rat and a human? Now, rat has some sense of taste, some sense of smell. It can see. It can do a lot of things which are similar to that of humans. But there could be something, the body shape and other things might not be same as humans, but there are certain genes in these animals which are similar to that of humans. Now, in the genomic data analysis, the project, what we did is we were trying to identify, reduce the drug discovery time. Now, if you're looking for a drug to be released, for example, COVID vaccine to be released, it has to go through multiple set of processes, right? So it has to go and test it on rats, it has to test it on rabbits, monkeys, chimpanzees, and then on clinical trials of humans. And if everything passes, then it has to release the drug to the market. Now, this is a very huge process, right? So, you have to do a huge testing. To reduce the testing time, what has happened is, whenever the initial testing is happening, imagine on rats, what we do is you take the samples of that and identify what are the genes which are similar to the rat to that of humans. And if we identify the similarities, if there is a positive result of a drug on that particular gene, then what we can extrapolate is we can say that because there is a positive result on that particular gene, the same drug might have positive result on the humans also. Likewise, we can do the extrapolations and then can use this entire process to do futuristic predictions. So that is called as genomic data analysis. We are trying to identify similar gene patterns between animals and the humans, and then testing the drug on that particular genes. If it is having a positive behavior, what we can extrapolate is the same gene will have a positive behavior in the humans also. Likewise, the testing time of the drug is reduced drastically. So if it is taking a lot of time, we are seeing that the COVID vaccine, it is taking a lot of time to come out, and some people are successful in experimenting, getting initial rounds of vaccines and so on. But if you see, the drug discovery time is very, very large. The reason is because it has to go through this stringent process, because if they create a drug which is creating some side effects and that is released to the greater public, then what you see is you get a lot of lawsuits filed against the drug company. So such kind of things, if to avoid such kind of things, drug companies will be very, very vigilant. There are FDA authorities who will be providing approvals, even in India, abroad, and other places also. There are different drug authorities which will be providing approvals of these drugs, and they can get approvals only after all this testing is done. So to reduce the drug discovery time, data science is helping in a great manner. So there is a question like, how do we identify characters of a person? Is that done by coding? Yeah, so we have to code accordingly. So in codon, I am not aware about the codon part, but what you do is we can apply deep learning based techniques. So you're talking about the gene sequencing, right? Gene sequencing is basically based on using DNA sequences. Yes, yes. So when you get these codon sequences, right, the A, G, T, and C, and so on, so you get those patterns, and then when you find out those patterns, you will have a similarity in the patterns, and that could be used. Yes, I was thinking you were talking about coding and something. Now, how do you find that? How do you find the pattern? In sense, whenever the genes are provided, so in the gene sequences, when you get the DNA samples, there are apparatus which would provide the DNA samples, and with the DNA samples, you would be getting the parameters. Now, I actually do not know like how the parameters will be there, but we know like how to work on the similarity of the patterns. But for similarity matching, we could use a lot of machine learning algorithms. Back in those days, we used clustering technique, in which we would find out similarity in the pattern matching. There are algorithms like cosine similarity, where you will be creating vectors of these genes, and then when you create vectors of these genes, and when you put these vectors in an n-dimensional spaces, you can identify similarities in the vectors based on cosine similarity. Okay, so that is an algorithm. I might be going a little deeper into explaining all that stuff, but bottom line, what we do that is we try to find out similarity of these vectors, and that similarity we will try to apply the algorithm, and which will tell that which genes are similar, which genes are not. It's a cosine similarity. So you can search for something called as cosine similarity, which will be working on vectors. So what we have to do is we have to do the transformations of these patterns in form of vectors, and after that you would be applying this similarity. Got it? Great. Thank you very much. So let us continue. So it is an interesting project. Another interesting project is Internet of Things. Now, what is Internet of Things? Now, Internet of Things is a very, very promising area in which it is combining IoT, sensor data, then cloud computing, data science, all that together, and creating holistic applications. Now, this application is, if you do not know about Internet of Things, it is nothing but every device we are looking around, right? Everything which we are having, everything we are looking around, it will be connected to internet. All right, it is connected to internet, and then we can use internet. It will be connected to internet, and we can use the data of that device, and which can be sent over the internet, and then we can use it for the purpose. So such kind of things is called as Internet of Things. Internet of Things is basically we're trying to apply these systems, where we are trying to use the systems where we are capturing all the information of the device, and we are sending it to a cloud-based provider, or like a common place where the data can be analyzed and we can do better systems. So this was an application which is done for a car manufacturing company, and this is a huge car manufacturing company, and they have so many machines which are doing a lot of things, and they are connected in a production line. For example, machine 1 does something, and then machine 2 does something, machine 3 does something, and so on. So the car will be going through this production line, and the parts will be assembled, and a lot of things will be done. So every day the machines, you have to test the health of the machines. So the supervisors, what they do is they go to every machine and they capture all the information of the machine. For example, some vitals like what is the temperature of the machine, what is the viscosity of the machine, lubricant fluid, what is the turbulence of the machine, whether if it is a cutting tool, the turbulence should not be beyond a specific limit, right? If the turbulence is very high, then what you see is there is a lot of disturbance in the cut. So your turbulence should be very, very smooth. So all these things will be considered in this Internet of Things. So what they do is they try to capture all this information, and then they take some meaningful decision that okay, this machine turbulence is very bad, so that they might have to change the lathe. Lathe is the cutting tool, right? So if the turbulence is bad, they might have to change that lathe. And so like that, if the temperature is beyond some limit, they might have to change the lubricant, coolant, and something like that. They will take the decisions, and accordingly they will behave. Now, how they understand all that stuff is basically, looking at these all conditions. Now, with the Internet of Things, because the supervisors may not be very experienced. So if there are new supervisors, what they do is they don't want to get fired. So they will procure all these devices well in advance, and they will be lying in the godown, which is a loss of revenue. So to avoid that, what they do is we will try to apply Internet of Things. Now with the Internet of Things, all these devices are connected with the sensors. Now the sensors, what they do is they will try to take all this sensory information. So they will try to apply a lot of related things, and they try to get all the patterns of the data. For example, there are temperature sensor, there are viscosity sensor, there are gyroscopes which are measuring the turbulence of the machines and so on. So taking information from all these sensors, if we can use data science, we can create applications which can identify the patterns in the sensors and then do the predictive analytics. In the predictive analytics, they will predict that so and so sensor, the turbulence of the machine is beyond the threshold limit. So and so machine, the temperature of the machine is beyond the permissible limit, so that the machine will go bad. It can clearly predict within 2 weeks in advance that so and so machine will go bad, provided all those parameters are matched. So using Internet of Things with a combination of cloud computing and data science, huge applications are being created where we are make using of these all technologies and then creating better systems, so that there is no loss of revenue. For example, we don't have to store the machines in advance, and all those things can be done. Got it? Next interesting application areas are these voice assistants, like you can say Google Assistant, Cortana, Alexa, Siri. These are all equipped with a lot of text-based information. They use something called as deep learning-based models, recurrent neural networks. And what they do is they will create systems where it can respond, where it can take the text, respond to the text, and do a lot of applications. Right? These are all also very interesting. And next other interesting application areas are the personalized medicine applications. Like personalized medicine is a very also important use case in healthcare. So what are personalized medicine applications? For example, now what I wanted to say is, if at all there are two patients, one patient is very fat and the other patient is very thin. Imagine, both of them are getting fever, and the doctor has given one dosage of crocin to both of them. Okay, so one person is very fat, one person is very thin. The doctor has given one dosage of crocin or any paracetamol to the patient. The guy who is very fat, it did not work. The dosage of crocin did not work. So he will come back after 2 days and say that, doctor, you gave this one dosage of crocin, but it did not work. I still have fever. I am suffering from fever. So what doctor will see that, okay, it did not work. So he will increase the dosage. He will say, take 2 dosages of crocin every day. Now the patient will take 2 dosage of crocin. After 2 days, he'll come back saying that, okay, my fever is gone. Thank you very much. On the other way around, for the patient who is very skinny, who is very thin, one dosage of crocin might have some side effects. Okay, after 2 days, the patient will come saying that, doctor, you have given this crocin. I am having severe side effects. I am getting headache. I am getting vomiting, nausea, and different other sensations. I'm also feeling very weak. Now, what we are observing from this, that one dosage of crocin is not common for everybody. Okay, sometimes depending upon a lot of physical characteristics, some physical parameters, the medicine has to be personalized. No, the medicine has to be personalized for age, for gender, for lifestyle habits, for height, weight, and multiple other things, right? Different other things are there based on which the medicines have to be personalized. If the medicines are not personalized, either they will have serious side effects or they will not work. Like the example what I've taken. For the fat guy, it is medicine is not at all working because he required a double dosages of crocin. But somebody who is very skinny, for that person, it is having side effects. So it is very important to have a personalized medicine. Now, using this, there is one popular hospital chain which has worked on the project, which is done. What they did is they have taken a lot of medical records of the patients. Okay, so when the person goes to the hospital, they will do something. They are doing something called as they'll take something called as EMR. EMR is nothing but electronic medical record. Electronic medical record is the record of the patient, is the complete history of the patient. So what is the patient, what is the age of the patient, height of the patient, blood group and different other parameters. All those good things about the patient will be considered. They will be also taking the bodily vitals, what is the blood pressure, blood sugar level, different other parameters like creatine, serum levels and other things. They will take all these parameters, all the body vitals, and then store it. Now imagine we use data science algorithms like clustering. Clustering is a technique in which we try to group similar patterns. So what will happen is we will be grouping all the similar patterns, like all fat people will be grouped together, all skinny people will be grouped together, people who are having a general build will be grouped together, people who are fat and do exercise and do yoga or do some other related activity, they will be grouped together. Likewise, I'm creating some general examples, but what we will see is we will try to create applications which are having plenty of such kind of this. Got it? So when you're personalizing this entire systems, when we are personalizing this medicine process and all of that, you will be able to make better systems. So you can serve them better depending upon their age, depending upon their gender, depending upon their withstanding levels. A lot of these kind of conditions can be there where you can use all those things for serving your customers better. Got it? So that is called as personalized medicine. So there are plenty of applications. Now we have almost spent more than 2 hours understanding what are the different systems, how the data science is used. So by now you should have got a very clear idea about what is this and how to use this technology and how to use it for better understanding. Okay, any questions on whatever we have discussed? Are you guys following?
Yeah.
Any questions on?
Sitaram, I have one quick thing. Hello. What is exactly NLP?
NLP is called as natural language processing. That means that if I have a natural language text, if I want to do analysis on the natural language text, understanding the sentiment or review or whether to find out whether it is a spam or a non-spam email or trying to categorize that content, for example, entertainment, politics, different news articles you try to categorize, right? So all that work will be happening in NLP, like creating chatbots.
Okay. Can I say voice assistant will come under this NLP?
What is it?
Voice assistant.
Voice assistance partly can come under NLP because if I'm doing text-based processing, with the voice assistant, that will come as NLP. But voice assistance is beyond just the text part. It is also having voice conversion, converting from your speech to your text or speech to some question. So all that thing will be part of something called as deep learning.
Okay, got it. Thanks, Sitaram.
Okay, so any other questions? I thought I'll give like few 10 minutes for some question answers related to the topics.
Sitaram, this is Prabhakar here.
Yeah, Prabhakar.
Yeah, we discussed about like 4 cycles of analytics, right? Like descriptive, diagnostic, predictive, and prescriptive analytics. So I have a question, like where exactly the data science part will fit into this analytics?
Just a second.
Yeah.
So, so the question is like where the data science fit into it. So as I told, so the different analytical processes like predictive, descriptive, prescriptive, and diagnostic. Basically, those are the analytical process where we can create models to understand those things. But the data science is more of a connecting tool. As I told, data science is the one which is driving that analytical processes. So for doing that analytical processes, I might need to collect some data. I might need to do some processing of the data, then apply the data to find out the description and so on, right? So the 4 analytical processes are there, right? The descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Now, those all will be used in different senses. And what we try to do is we will use one of those, you know, one of those techniques to apply the modeling and then understand the data. But data science, what it does is it connects everything right from the start till the end. Everything will be connected for doing this analysis. So you can think like it is more of a overall thing which connects all these things for performing those analytics. Did you get it?
Yeah, I got it, Sitaram. So let's say that once we have the data, and then we'll do some kind of data mining, and on top of that, we'll be generating a patterns, post patterns, right? So it's called like we'll be having an algorithm to create the patterns, and then you will be creating a wrapper kind of thing, like a model on top of the algorithm, and deploy this one in a production instances, right?
Correct.
Okay. So in order to become a data scientist, so what kind of qualification or experience is required to acquire that knowledge?
Yeah, so that is a 1 hour topic to discuss. In fact, I will talk about that tomorrow because we would have people from different domains and knowledge levels and experience levels and so on. So tomorrow, what I will do is I will talk about the entire life cycle of data science, and then we will understand, which particular role will be suited for what type of people. Now, when I do training, right, I see many people who are of different experience levels. So somebody will be like 10, 12, 15 years of experience who have already seen a lot of working. They might have already worked on previous systems. They might have worked on Java, mainframes, or databases, data warehousing, anything like that, previous career. And now they want to switch into data science. Now, for them, there is a different path. Okay. And somebody who is just out of the college or might have a couple of years of experience, now he has done some computer science, or he has an understanding of Java or something like that. Now, for such kind of people, there is a different path. And within the data science gamut of technologies, there are different roles. Okay, so there is a data scientist role, senior data scientist role, data engineer role. There is a machine learning engineer role, DevOps engineer role. Likewise, there are different engineering roles also, which will fit for multiple applications or roles. So I think we would require a little detailed understanding of that. So I would park it for tomorrow's session, because we will spend at least 1 hour understanding that. Because it's not about learning things. So whenever you are because there are almost like 60-70 people out there here, all these people, you're attending this session for some reason, right? Everybody is not mad to spend their 2 hours over a weekend, and that too in US it is a long weekend. So you're spending for certain reason. So when you're thinking that, you need to understand what is this entire scope, what is the future, and where it will fit, whether that will fit for me or not. All these things are really important questions, and everybody needs to understand tits and bits of that. So I think we will spend some good amount of time tomorrow to understand that, and based on that you could take some decision. But certainly it is a very, very important question.
Okay. Yeah. Thanks, Sitaram.
Great. So there is a question that, could you say data science is a package of data analytics, data modeling, development, and visualization? Exactly. Yeah, you can call that. And data modeling again will involve deep learning, machine learning, and different other things, right? So artificial intelligence is also a thing. Artificial intelligence is a concept. Data science is a process, right? If you are understanding what is artificial intelligence and data science, artificial intelligence is a concept in which we are saying that, okay, if I do this kind of rule-based things, this will happen. But data science is a process in which we're saying that, okay, I'm getting data, I'm doing this processing, I'm doing exploration, I'm doing modeling, I'm doing deployment, production, and all that stuff. That is how it works. Got it? Any other questions? Any general questions you have? So generally in this data science workshops, I will get a lot of questions related to the science, what are the requirements, what we need to have as a prerequisite, like that. Anything?
Hi, how to get support from you or after getting into a project?
So regarding support, it requires like how much of support is required. If you talk about say complete support where somebody needs to completely assist you, that I don't think it is possible. But generally, what we approach is we will provide training. The training would be provided for say like 3 months duration, and within that time frame, you would be very, very comfortable. But after that, you will have a handheld support. So you can call us if you have a new project, you're having some discussions, creation of application, you're held at some point, or you're held at a point where you're skeptical about using a model, algorithm, or a process. So such kind of support would be provided, but the support would not be extended to you give the project and we do the coding. Such kind of things would not be there, but a support with respect to hand holding, right? So that will be provided. That would be extended up to 6 months. By that time, you would be very, very comfortable.
So that's only available for those who gets the 3 months of training?
Generally, for people who get associated with us, like I am not saying only people who get training, but certainly you have to get associated with career IT if you wish, right? So then that would. I would recommend please do get in touch with the career IT team. They would be able to provide even more information. I'm more of a technical guy, so my purpose and role is completely different.
Actually, we only need technical expertise. Actually, I really need hands-on expertise who can really support and answer the questions.
Yeah, certainly. I think I would recommend you to come through the career ID. Definitely, we will understand your requirement, and if we can do something better, definitely we'll do.
Okay.
So basically, what timings you conduct training classes or sessions? In the evening or
Generally, it will
morning?
be morning time India time mornings. Generally, batches would be there from 6 o'clock, 7 o'clock, 8 o'clock. Different timings are there. Again, different batches will be there. And
Okay.
there is a batch which we are planning to start at 6 o'clock morning, which will be US time in the evening. So I'm not sure from where you are speaking. Are you in India?
I'm from Melbourne.
Where?
I'm from Melbourne, Australia.
Okay, for Australia, that would be it would be afternoon or late evening then. So if the training is in the 6 o'clock morning, I think I'm adding like 5 hours from India time, right? So somewhere in afternoon would be the time for you.
Okay, I'll get touch with in like career IT team and to get more details here. That's fine.
Yes, please. So the trainings generally happens in the morning because I work, I also work. So my general afternoons and evenings would be busy with some meetings and all. So even if I take some batch, it would not give a right amount of concentration and attention. Generally, it will be in my mornings, 6 o'clock, 7 o'clock, 8 o'clock batches would be there. Based on the batch timings and all, people would join.
Okay.
And the training would be generally for 3 months. We go in a very detailed manner. If you are interested, I will be sharing the curriculum also. Maybe tomorrow we'll look it for a few minutes. Not, but this is purely like a free workshop. It's not just for vouchering for our batches, but certainly we want to share some knowledge. Any questions you have related to that, we are happy to have. Not a problem.
Okay, sure. Thank you.
So anything general we want to talk about the today's topic, I will spend a few minutes to discuss about that.
Like Sitaram, this is Prabhakar again. Going back to the one of the slide from today's topics, like is machine learning or machine language is required to pursue data science?
Not necessarily. So machine learning is more required when you're trying to do more predictive analytics. So there is something called as descriptive analytics, where we are explaining the current data. When I'm explaining current data, most of our current business analytic processes works on descriptive analytics. Like for example, I would like to know what is the status of car sales for Maruti now from the month of January. So month of January I have data, month of February I have data, March, April, May, June, every month I have data. So looking at the data, I'm going to explain that month of January till March, the data was good, car sales were good. But after March, the car sales declined. Now that could be different reason. Now we know that the reason is COVID, but with the data we are able to explain. Now for this descriptive analytics, we would not require machine learning, right? A lot of descriptive analytics would be able to provide us some kind of understanding of the data, the patterns, and we would also make sense of some forecasting also. Like looking at the past information, we would come up with some kind of understanding. So some of the metrics, for example, mean, median, mode, variance, standard deviation, those all are very important metrics which would give some key informations. Those all does not require machine learning. But many businesses are wanting to go beyond descriptive analytics. They want to go to predictive analytics. They also want to go to prescriptive analytics. there we would need this understanding of machine learning.
Okay. Got it. Because the reason why I ask this question is, let's say that we have different cloud platforms like AWS or Azure. They're providing their own services. Like, let's say that AWS has a SageMaker service, which is kind of an integrated platform where we can train the model, build the model, and test the model, and later we can deploy it. So my question here is that, do you need to go to the scratch of this understanding of the machine learning things and come with some kind of a language, kind of Python or R programming, then
Right.
create the models on top of it? I mean, do you need to follow this kind of a process to be a data scientist? Or, hey, I have the services available, I'll utilize the services and build the models as per my requirement and deploy it as per the customer requirement? So that's why I just want to
Yes.
understand which is the right
Correct.
way.
There is no requirement. I would say there is really no requirement if you're only focused about that. But the problem is there are a couple of problems involved in that. So if I am an AWS person, if I will be strict to that AWS related tool ecosystem and all, I can only use those tools for doing this process. So I can certainly do the same process, but I would be vendor logged in. Imagine I don't want to be vendor logged in. I want to be open. Today AWS is there, tomorrow it can go down. People can move to Google Cloud, and that will become the next big thing. So such kind of problems will be there. And even customers do not want to get into vendor logged in positions. So there are tools, proprietary tools provided by these cloud providers, but that would expect the data has to be in that cloud. There is certain kind of vendor restrictions are there. So people want to go more with an open applications where they don't have this burden of a specific vendor. So that is the reason. That is one reason where people do not fully stick to those kind of products. Okay. The second thing is, because these products are very nascent stage, they will be having some predefined setups. Like they will use predefined algorithms, predefined setups, some hyperparameters, and so on, which might not be fine-tuned for every data. Now that becomes very important. Now I can use one tool, but if it is like giving only me like 80% accuracy, and I can't do any customizations to that. Right now, I say build a model, drag and drop positions are also there. I can select some model, give the data, and then get my output. Now I am using it. It is giving 80%, but provided if I have done some more customized training, customized processing, I would have got like 90% or 95% also.
Okay. So you mean that the services which are offered by AWS or Azure will not give the accuracy of your models like beyond 90 or 95 or like that?
Yeah,
I mean,
they are not correct. I mean to say, I'm giving an example because they're not custom built. They are like not what I mean to say, you can't customize to so many varieties, right? So there is a fixed set of algorithm used, fixed set of process used. So they are making they're ensuring that the data, the particular models are suited for a lot of them, but those your data might not be exactly suited for that. So it is always recommended to go for some kind of customization. And one other thing is that when they are predicting, the model is predicting, you need to understand why is it predicting. So the why angle, there's a lot of research now happening on explainability of AI. So these tools are missing that explainability part. Why is that happening? If somebody is asking like, why is this happening? Now when I'm hand coding some of the things, you would know like, okay, because this is the pattern, this is the nature of the data, this is the reason so and so thing is happening. So you would get that kind of a little clarity of what is happening, why is it happening, and how is it happening. But that will be missed when you are doing this black box kind of a thing. But I am very confident that in the coming years, so cloud is going to rule the world, of course, and it will come up with all these data science related tools, Already it has started coming. You already talked about Amazon SageMaker. Similarly, everybody is providing their own similar kind of tools, and that will come up with all these kind of optimizations, hyperparameter tuning, and advancements, and so on. And when it reaches that stage, people will go there. And now at this point, people are still sticking to a more custom-based coding because you have that flexibility rather than using a cloud provider and getting logged in.
Okay, perfect. I got your point, Sitaram. Yeah, thank you.
Great.
Hi, Sitaram.
Yeah.
Sitaram, you say it's 3 months course. I'm just wondering, is it for beginners or intermediate or advanced?
It is for everyone, but I will start it from very basics. So very basic from low level till advanced level. But it would expect you to be technically want to be technically involved, because that will be a technical course. It will be not like a business nice to have listen course, because we have to do exercises. There will be a lot of assignments you have to go through. At least we will be doing 20 projects, so you have to go through all these entire setup, right? So it is a technically involved course, but it starts from very basics and goes to advanced levels of deep learning, image recognitions, creation of chatbots, and all that stuff.
Okay. So example, I'm in Salesforce, right? How is it going to be helpful for Salesforce developer?
Salesforce developer, there are applications related to customer support and all that stuff, automated ticketing processing. So there are some applications related to that which would use some Salesforce knowledge. But the thing is, like, whenever we are using that information, how we can use that information and create some applications which can do automatically, like predictive kind of nature, automatic approving, and so on. Such kind of applications are being developed, and maybe that is an area which would help. It's all about.
Thank you.
So as I know, like I'm not sure in which Salesforce related division you are, but a lot of customer support, ticket management, all those things, that were projects which are a combination of Salesforce and data science.
Got it. Thank you.
Any other questions?
Yeah, may I know that what are the prerequisites to learn a machine learning?
Prerequisites means at least you need to know some language, not necessarily Python. We would be learning about Python in this course. We'll be starting understanding some basics and then going to Python required for data science. But you need to understand at least one programming language, maybe C, Java, C++, or have an understanding of some programming background. That will help. For somebody who does not have a programming background, it is recommended to have at least some language understanding. It will not take 1-2 weeks to go to something or something to get that understanding.
How deep knowledge you need it in that particular language, or just a basic or core concepts enough for this?
Basics is good enough, yeah, because I would be talking about advanced ones. I would go from basic, but I would not say this is the integer, this is the variable, this is how I define this. Those all things I would not be talking. If somebody even do not have that kind of understanding, I would recommend them to get through that. But things related to data science and all of that, related to Python and all, we will be talking. But people should have an understanding of how the code will be written, what are functions, what are variables, or how the nature of programming works.
Okay. Like, how do you distinguish between a data analyst versus a data scientist? Sitaram, in a project, we have like a couple of roles here.
Yeah.
And I, as a data analyst, they used to do a lot of work, and other than mining the data or slicing or dicing the data, we do a lot of work in terms of creating the algorithms as well as deploying these algorithms into a model kind of thing. But how exactly data scientists will come into picture in a project, and what kind of value it will be provided by them to their projects, right?
Yeah. So so I would say data analyst is the small brother of data science, and in fact, different companies have different ways of representation of the job role and work. If it is a small company, the data analyst will be the sweeper, cleaner, everything. Like like he will be the person who is be doing everything. But generally, from a job role perspective, data analysts are the ones who are like a little lower to the data scientist. And what they use, they use the tools like Excel, SQL, or basic data munging. They will be using some small modeling tools like for understanding data patterns and so on. But primarily the work would be on Excel, SQL, and other things. So they can write some queries, join some things, get some reports, and maybe apply some models and get the results. So that would be the primary skill set required for a data analyst. But a data scientist would go a little into the modeling, right? Creating models, applying. Even the data analyst would also do data pre-processing. So he might write some joins, do some filtering, selection, subselection, grouping. All those things will be required. But the primary skill required is SQL. So somebody who is from a data background, database background, can be a very easy fit for a data analyst, right? So working on SQLs and so on. But it will be limited for doing analysis of a specific report or a specific spreadsheet or a database table and so on. But when you go for larger data processings, that skill set will be a little short, right? So now there will be an overlap between a data analyst and a data scientist. That means that a data analyst who knows also how to build models, who knows also to work on cloud-based providers or file systems and using these newer models for applying on them. Now that will be like a slowly transition from a data analyst to a data scientist. Got it?
Yeah, I got your point. And does it require any kind of an experience, like because when I see the jobs here in US, like they're asking for you should have masters in mathematics, or you should be a statistician, or you should have a PhD degree to apply for this data scientist role. So my question here is that does it require any kind of education qualification to apply these kind of jobs once you complete this training?
I would, it is a debatable topic, in fact, because some of the companies require PhDs and this thing. And that is because of their job roles, their primary requirements of the job roles and all. But I know so many data scientists who just are BTech graduates and who are still working here in India and in US also. And they are doing pretty good. What I would say is we need to have a lot of project-oriented learning. We should be able to project our skill, and the way we have to do it is a different. So I also talk about an approach in which we build our social profile, ensure that we have presence on GitHub, on LinkedIn, and vouch for our work and all. So if you improve that part, we don't have to concentrate on these job portals who will be wanting PhDs and all. So they are like tick mark kind of roles according to me, which the company has to say that, okay, we have 10 PhDs who are working in the data science team, but the actual work will be done by a regular BTech guy or a MS guy, right? So according to me, that is what is a thought, right? I don't too much rely on doing a degree, but there are companies who are looking for that. I think an easy ask would be somebody who has done masters, right? So masters at least I think is kind of a requirement, but somebody who is already having good experience, who has done his graduation, has good experience and can project his experience, right? So what I used is we have followed a methodology in which we need to get social presence, right? I have followed it for many of my past students. In that, what we do is we try to improve our social presence by in terms of articles and videos, and in terms of posting some content on LinkedIn and so on. And what happens is that will increase your social presence. You do some model and then you explain that on the on LinkedIn. And what happens is you get the presence, and then you get the job roles. You get calls. You don't have to wait for. So it's not like an inbound approach, but it's like an outbound approach. Or sorry, it's not like an outbound approach, but it's an inbound approach. So when you do that, such kind of things would work. But yeah, we have to do our homework.
That's really great. Yeah, thank you, Sid.
Yeah, so like a couple of questions are there. Let me answer them and then go forward. So there is a question, a very interesting question. In fact, I would talk more about tomorrow. So there will be multiple teams related to departments related to database or modeling, development, transformation, reporting, analysis, and all. Now, as a data scientist, the question is, do we need to do everything? Right? It's a bigger question for a process. The simple answer is no, but a lengthy answer is yes. So how that will be done, I think I will park the question for tomorrow, because we are understanding that entire life cycle and we will be understanding all that stuff. So in that case, in that sense, I will talk about that in a great detail. It will definitely take a easy half an hour discussion. So we are almost 2.5 hours to 3 hours almost listening to me. Because you guys also need to have so much of patience. So I'll park it for tomorrow. Okay. Another question is experience as a commerce graduate. So if people from a different background, so I have trained a person who is having in a mathematics background, and people who are in a different background can also come. But what I would really urge them to do is try to do their homework. Try to identify areas where they can go. For example, people who are having academic background, or who are having some commerce background, or having some other background, if we want to merge or come into the data science, if I say that I want to come into the programming and then I want to work in a software company and work in a bigger role, then they will certainly look at your past background and they will have questions. Now, what I want to identify is identify the change areas, identify the application areas where your role can be easily suited. So the person which I was talking about in the mathematics background, he has identified in a research application where they can use both mathematics and data science, and he got a very clear cut role. So identify whether within your company, if there are any any applications, for example, in the domain of healthcare or retail or any banking, if there are any roles which you can switch to first. And once you get some experience, then you can switch to a better role. So the first chance is very, very important. So once you get that, you definitely can sustain for longer things. And the previous answer which I was giving, also having
hello. Sitaram garu, sorry to interrupt you.
Yeah, madam.
Can you speak for a minute?
Yeah, go ahead.
Yeah. Hello everyone, this is Lakshmi from Career IT. Thanks for attending the session. And tomorrow also we are going to have the session for 3 hours. And we have one more information from our end. We are going to have the data science regular batch from the next weekend onwards. And we do have Python batch, Python with Django will be starting in the next week. And we'll be having demos also for that. We'll be sharing those details also. And we are going to share this recorded session through our YouTube channel. So please subscribe to our YouTube channel for getting more free sessions and even about regular batches, whatever we have. So please do that to get the recorded sessions of our sessions. Thank you. Sitaram Garu, please you can carry on.
Okay, ma'am. Thank you. So whatever I was saying is everything is doable. The training would provide all the assistance and help and all to get the switch. But I would really urge you to do that research well in advance, and then based on that, you can take a step forward. All right. Any other questions? I think we are almost approaching to the end of the 3-hour long session. I really appreciate your patience for listening to such a long time over a weekend. Thank you very much, and I hope you attend tomorrow's session. I would be talking a little technical tomorrow. Today's was a very general session. Tomorrow you will have an interesting discussions about what are the different applications, how is the life cycle, what is the difference between data engineer and data scientist, how different roles are working, what is the life cycle, how we do different applications. All those things we will be discussing in tomorrow. So tomorrow also the same link and same time. I hope you guys attend, and thank you very much, and have a nice day. Stay safe and stay healthy. Bye bye.
Thanks, Sitaram.
Thank you. Thank you so much.
Thanks, Sitaram.
Sitaram, and meet you tomorrow.
Thank you.
Thank you, Sitaram.
Thank you very much. Bye bye.